welcome to today's webinar, Driving Innovation Safely, Securing Software-Defined Vehicles from Code to Road. I am Bethan, the Content Editor for Automotive IQ, and I'll be hosting the webinar today. Software-Defined Vehicles, or SDVs, are transforming the automotive industry, bringing with them advanced safety features, seamless connectivity, and an entirely new driving experience. But with innovation comes a growing concern. How do we ensure that the software that powers these vehicles remains secure from cyber threats? Today, we will explore the evolving attack surface of SDVs, the most common vulnerabilities in critical systems, and proven strategies to protect them. From secure software development practices to real-time runtime protections. We're really happy to welcome our speaker today, Joe Saunders, who is the founder and CEO of RunSafe Security. Joe has a deep expertise in software security and will walk us through challenges facing SDVs and provide actionable solutions to mitigate risks. Before we get started, please make sure you ask your questions in the Q&A box to the left of your screen. If you have any questions surrounding automotive cybersecurity or current SDV challenges, please ask them throughout the webinar and we'll do our best to ask them at the end. There are also some polls to the right for you to answer and some additional content links for you to click through. Okay, Joe, I'll now pass over to you.
Thank you, Beth Ann. Thank you, everyone, for attending, and I'm happy to talk about this important topic today. What I wanted to do is start with, a few key points setting the stage around, software-defined vehicles and what's driving, part of the issues related to new vulnerabilities discovered and potential attack surface problems targeting and cyber attacks targeting such vehicles. So I'll talk about the software-defined vehicle attack surface, and then talk about vulnerabilities and the best practices with it, and then also get into some other mitigations and strategies going forward. But I think it's important then to start with what's really driving the software-defined vehicle space, and what can we expect from it. And what we've learned over time, as you can see in this software-defined vehicles report, is that the growth of software-defined vehicles is quite large. And by 2030, it's exceeding $600 billion, $650 billion. And that's accounting for 15–20% of the entire automotive ecosystem. And I know there are a lot of investments going on in the automotive sector. There's a lot of transition. There's a lot of economic changes. Of course, the automotive industry today is facing tariffs in some ways, but also there is a focus on future value that automotive providers can bring. And this represents a good capture of why this software market and why this segment and why the automotive segment is so interesting in today's environment. So we look out the next 5 years and we expect a lot of growth in software-defined vehicles. And I like to think software-defined vehicle, we used to think of a vehicle, with some gadgets, a radio. Then we thought of a car with a computer. And today I think of it as software with wheels. And the software architecture, the systems platforms are quite significant on these software-defined vehicles, and the capabilities are also quite interesting. And so, what is fueling this growth in software-defined vehicles? And I think you can think of it in two aspects: the value proposition to consumers, or the benefits that they can receive both in having connectivity in their vehicles and even personalized service and certain forms of automation or infotainment, but also even driving assistance and better safety measures ultimately. So there's a lot of different benefits from the consumer's perspective, but there's at the same time significant benefit coming from the industry by way of innovation, by way of technology, and by way of new services being offered. So we're all very familiar with the notion of autonomous driving, with electric vehicles, but even just as important over the past several years has been this push for over-the-air updates. And if you think of a software or a car as a platform on which software is deployed, you can imagine, just like with a cell phone or other devices, pushing software updates enhances security, enhances service that can be offered, and features and functionality that can be offered to a car on an ongoing basis. So updates can occur safely over the air, and products and software can be patched. So autonomous driving, electric vehicles, over-the-air updates are all significant innovations that have been steadily improving over the past several years, and it's only accelerating now, which is resulting in that consumer benefit for those who seek newer cars. And with all that connectivity, it also means there's still chance for more opportunities to secure platforms. Why? Because there is so much more software code. There could be up to 100 million lines of software code on a vehicle, and that translates to anywhere from 40 to 70 to 100 different kinds of software packages or applications that are deployed. And we think of them in groups. We think of autonomous driving. We think of infotainment. We think of the systems that interconnect and the engine control units and the like. They all have software components. Naturally, we all know cars used to be very mechanical, but this digitization of how cars operate is a major driver. And with more software, it means we have a chance to find ways to generate more security for these applications. So if we see massive increase in software-defined vehicles for the benefit of consumers because of the technology innovation, we need to be mindful of the software practices and the security practices, because it means there's so much more attack surface with the hundred of millions of lines of code and the different software packages that are deployed on vehicles. So with that said, I think it's important then, if you look at the diagram on the right, to see all these different dots that are out there. Those represent, just a sampling of places where software applications are deployed that can enhance that experience, can enhance safety, can enhance security of a vehicle and provide, additional value. It also, gives automakers new revenue streams to drive enhanced experiences and the like. But with all these dots over to the right, you can see there are things that power mirrors, things that power infotainment systems, things that power braking systems. And what has happened is, just in 2024, as we've seen from the automotive and smart mobility cybersecurity report that just came out in February, there are automotive attacks that have happened. 92% of those attacks, if you think about the connectivity on vehicles, have originated in remote ways. So remotely executed attacks, 92%. In addition to that, these attacks have the potential then, given common software that's across different vehicles, common open architectures across vehicles, that those attacks could affect up to 70% of vehicles or devices on those vehicles across different, even manufacturers, because there are common suppliers, common software packages that are involved. So you can see it is a very significant, situation here. And then with that said, 35% of those remotely or of all the cyber attacks from 2024 were in fact involved some form of car system manipulation. Now we can all fall back to 2014, 2015. For those that remember the widely communicated and covered in the media cyber attack on a Jeep that was administered by Vlasic and Miller, they demonstrated that you could steer a car off the road. And certainly since that time, I believe that was one of a few things that contributed to the industry taking security very seriously. Naturally, the other was that I think the industry knew that innovation was coming and more software was coming to vehicles. But certainly if you combine those efforts, the industry has come a long way in the past 6, 8, 10 years to think about how security can be added to these vehicles given the attack surface. And before I get to the common vulnerabilities, I'll just say, there is a key element here that security, I think in the automotive industry, if you think about autonomous driving, you think about attack vectors that could affect car system manipulation in different ways. I think everyone would agree that security is really about safety. And so when safety and security are combined, it means, that we can build innovation going forward. And we'll get to that more in a second. And I think I mentioned this already, given where are some of the most common software vulnerabilities in software-defined vehicles. Certainly the autonomous driving and the infotainment systems, and some of the more recent attacks that were published January, February, were demonstrating in Linux-based environments and Android environments, infotainment systems could be compromised. And what we've seen is that attackers can move from there to other parts of systems. And so not all vehicles today are segmented from a security perspective, and people can jump from one component to the other. And then naturally, with the underlying real-time operating systems on ECUs, there's always the chance for vulnerabilities, whether it's in the supply chain or on the devices themselves, or manipulating devices through the CAN bus and other messaging protocols. ECUs are an easy target once an attacker's on board. So these are the common areas where attacks or vulnerabilities exist. And in many cases, the underlying software, like in ADAS, we have seen that the vulnerabilities are related to memory safety vulnerabilities, things like buffer overflows, things that are a result of software being written in C and C++, the so-called memory unsafe languages. And so these are areas where we can look at scale, how can you cut off an entire class of vulnerabilities and increase that safety so consumers can enjoy the benefits that are offered through the enhanced services that are made available on these cars. So a couple examples then I can drive into here is if you look at in 2022, a critical vulnerability was discovered in Tesla Model 3 vehicles. I hinted at memory safety vulnerabilities in general. This particular vulnerability, CVE 2022 42431, is a vulnerability that's classified as a buffer overflow. And buffer overflow is a classic memory safety vulnerability that ultimately allows an attacker either to escalate privileges and do things, or even reach the ability to execute arbitrary code. So if you think about some kind of hacker or a nation state or some kind of attacker doing something, when they can leverage memory vulnerabilities, that's what leads to some of those remote attacks and remote code execution, but also the ability to execute arbitrary code. And what that means is they can ultimately leverage the existing code and do something that wasn't originally intended by the original developer for that feature. And so that is why these kinds of vulnerabilities are very, very critical and ultimately get rated through the services as the highest severity scores in terms of the CVE system. The CVSS score, which goes from 0 to 10, oftentimes these kinds of memory safety vulnerabilities will be 8s, 9s, and 9.9s and the like, because they're widespread. A lot of damage can happen, and it gives the attacker a lot of room to do what they choose, and denying what the original developer had intended with the software. In a similar sense, researchers leveraged and exploited a heap overflow vulnerability and an out-of-bounds write error. These are also memory-based vulnerabilities on a Bluetooth chipset. And so if you think of all the communications, Bluetooth and radio and different access points, even the ones that enable over-the-air updates, on the receiving end of that data transfer and on that connectivity is always some kind of chip that converts that data package and that signal into code. that gets processed on the hardware on the system in the end. And what that means is it allows access points and then a memory-based attack like a heap overflow, which is really tricking the system to do things that it didn't want to do. And so these are very scary kinds of vulnerabilities. And of course, Tesla Model 3 systems are very good because Tesla is very good at software updates and having that connectivity. But at the same time, with the high prevalence of software that's out there, you can imagine that in the 100 millions of lines of code, potentially, there's always room for new vulnerabilities. And so how an organization responds to that is key. And yes, it could be patches that are shipped quarterly or monthly or over the air. But also, I think people can think about their security posture in a way that prevents these kinds of vulnerabilities by virtue of the software development lifecycle and things you can do at software build time. So these are good examples. Tesla having that CVE we talked about, which led to an attack built around targeting the heap, which is part of the memory and in software. And so these are common methods that attackers use to take control of systems. So with that said, I do think it's important then to step back and think about our software development practices and things that the industry can do by way of standards to help boost security and safety. And what we've seen is a dramatic increase in the overall software development lifecycle to enable security through better coding practices, understanding the threat modeling, and automating vulnerability detection tools. So having those tools and those methods built into the automotive software development lifecycle. In other industries, we look at DevOps programs that are automating all of these kinds of steps. There are also tools to add in at this point, the ability to add in security protections to prevent exploitation in the first place. And so it comes back to then process and methods that then ultimately map to standards. And that brings me to the safety standards. So ASIL, the automotive safety integrity levels, there's 4 levels. They align with the extent to which that software is putting passengers at risk, and what are the controls, what are the methods that are being enabled through autonomous systems. We all experience, maybe there's a detection that there's a car on your left and it's warning you. Maybe there's, a signal that you might be getting too close to a car in front of you. Maybe there's a braking aspect. Those are all different levels of severity of safety. And ASIL has 4 levels of safety classification that when it comes to safety standards, in particular for autonomous systems. And so with that said, you can imagine that if you have an improved software development lifecycle, but then you're mapping your safety standards to the software development lifecycle, you're doing the necessary testing, you're creating the necessary artifacts, you're reviewing how the safety controls are implemented, you're having that validated by a certifying authority as well as your own internal practices. ASIL is a very, very significant step for organizations, especially when it comes to software-defined vehicles. And ultimately, there are broader industry standards. I think we're all familiar with 26262, and ASIL is affiliated or part of that. But there are also standards like AutoZAR, or at least open architectures, I should say. Maybe not necessarily a standard, but common architecture components to help organizations be more efficient in terms of how they build software on a car and in the automotive arena, and what that open architecture means. And so you can see that if you have, again, a software development lifecycle, safety standards, and industry standards or best practices or common architectures, open architectures to use and reuse open source software on your vehicles. If you put all this together, there's a lot of work to be done, but there's good reason. And my colleagues, and one particular colleague of mine, my co-founder, Doug Britton, has always said, hey, it's amazing that cars take 3 years, 5 years to reach production from initial design of a new model in general. And we wouldn't ever want a car to be designed and built in a couple days, because we do want to go through these disciplined approaches to ensure, first and foremost, safety, then enhanced capabilities and benefits to the consumers or the purchasers of those cars. So you can imagine then, if the goal is to achieve high safety standards, have best practices in your software development process, automate the security testing, comply with industry standards, adopt open architecture, use things like POSIX to communicate and control different aspects of the vehicle, and have a common way to interface. These are disciplines that most automotive makers and tier one suppliers adopt. But when it comes to security, all the same questions have to be rolled into all of these same considerations. So software development has dramatically improved over the past 10 years, of course, and it's a serious topic. And ultimately, what ties it all together are the safety requirements in the automotive arena. And I would say that organizations in the automotive space realize that these kinds of regulations are good, and these kinds of expectations are good, and these kinds of standards are good, because we all want more innovative technology, and we all want safety at the same time. So with that said, I talked a little bit about a couple of these items earlier, but to kind of summarize different ways of protecting software that can be incorporated in an efficient way, given that complexity, the standards, the safety requirements, the software development disciplines, the testing and the retesting, and the certifications and the accreditations. All of that takes a lot of effort. And with that said, there are still things that can be efficiently applied. And so, naturally, over-the-air updates provide a means to address vulnerabilities and deploy secure patches, and also send downrange, if you will, the notion that maybe even new features can be pushed to a vehicle. But some of those features are simply patches and improvements and bug fixes. And so with that said, that's a key area, over-the-air updates, coordinating with real-time operating systems for consistent protections. So, I think we all realize that these proprietary systems, especially QNX and VxWorks, and there's other providers like Green Hills and even Lynx. These are real-time operating system providers, and they are built to provide a very reliable operating system in many industries, but certainly in the automotive industry. And part of the challenge then is, if they have vulnerabilities in their software, how do they get mitigated? And what's the implication for a vulnerability that gets discovered in one of these real-time operating systems for a vehicle that's on there? So now you start to realize that even the software supply chain and the supply chain of the automotive industry. So these real-time operating system providers are very, very important software players in the automotive ecosystem, and coordinating and ensuring you understand the security posture of an RTOS provider is very, very important in the automotive industry. And naturally, some people will say, well, it's tight, it's tied down, it's on an ECU, it can't be reached, or it's built in, into the chips or what have you. But given hundreds of millions of lines of code and vulnerabilities across there. Now, with that said, I don't mean to point out and say RTOS is the source of vulnerability. Certainly not. They are very, very good, but we do need to coordinate vulnerabilities with RTOS providers in how to handle those, just as we have to think about how to maintain security with Android operating system and embedded Linux operating systems that also are finding their way to these vehicles. Android, obviously widely adopted on infotainment systems. Embedded Linux becoming a great alternative, given innovation in build systems like with Yocto to create highly repeatable build systems for an organization. And so that can drive down the cost for vehicles, which of course, how do you do all this stuff with increasing cost levels to maintain this complex software ecosystem? So one way to find that is to look for embedded Linux and then work with that system to enhance security. Now, there is a common theme across all these systems when you think about vulnerabilities, and the reason the high remote execution, one, with the connectivity, two, with the number of lines of code, but three, in all this kind of software, there's inherently those same memory-based vulnerabilities that are out there. And so deploying runtime protection of systems, even when a patch or that prevents exploitation, even when a patch is not available, is also a key aspect of protecting software-defined vehicles and vehicles in general. And so protecting embedded systems in software at runtime, integrated into the software development lifecycle, is a great strategy because it can eliminate an entire class of vulnerabilities, namely the memory vulnerabilities. And those vulnerabilities often are anywhere from 40 to 70% of the vulnerabilities in these systems. It's true in Android operating system, it's true in Linux, certainly true in RTOS. If you go back to Urgent 11 vulnerabilities from several years ago, it was 6 or 7 of the 11 vulnerabilities were memory-based vulnerabilities. And I think we all remember the impact that had. So with that said, I've hinted at this, but you think about the benefits to consumers, you think about balancing safety and security and innovation to meet the market demand. Automotive companies have become software companies, and their software practices are essential to drive innovation. And certainly the ecosystem with tier one suppliers and other suppliers are bringing innovation to bear in the automotive industry. But with that said, all of those providers, all of that innovation, given the complexity of the supply chain, given the lines of code, the number of software systems on a vehicle, including an autonomous system, software security is now an undeniable component of vehicle safety, as we've established. So in the end, what we need to do to balance safety, security, and innovation is have these robust software development processes, have a robust way to distribute patches, but also have a way to add security into the process that meets safety compliance requirements. And so you can see how some of these forces might compete with each other. If I could just push all my innovation out fast, then consumers would be delighted. But that might not satisfy the security needs, the safety compliance programs, the safety requirements, and other industry standards that are out there. So we have to find ways to optimize this equation then. Maximize innovation as much as we can, minimize security vulnerabilities as much as we can, and ensure safety overall. So if safety is optimal in a world where there's innovation and security, then I think everyone wins. But then let's not forget the cost factor. So innovation brings maybe some economies of scale, some efficiencies, but also can create more overhead, more complexity, more systems, more hardware to process that innovation. And so we need to think about the cost structure of vehicles as much as the safety, the security, and the innovation. And so finding ways to efficiently do all of those things and bring it together is part of the takeaway here. And that is, these systems are vulnerable to memory safety vulnerabilities. And it's, software security is a critical component of vehicle safety, but focusing on safety and security will enable that innovation and ensure resilience against future attacks. And so I hope this is a good foundation to talk about, what's needed to drive innovation, to drive security, to drive safety in the automotive world. And I know I've used the word drive several times in this, and it's not lost on me that I'm talking about the automotive industry. So with that said, I'd be happy to turn it over to questions. But what I would like to offer up for folks is that we have a risk reduction analysis that is well equipped to analyze automotive systems and also work across the supply chain for an OEM to really uncover, those things that could put their safety programs, their security programs, and their innovation programs at risk. So here's a QR code people can do. But with that said, Beth, then I'd be happy to entertain questions if, since I was talking so much, I didn't see what came in, but I'd be happy to entertain the questions as you see fit.
Great, thank you, Joe. Just a reminder to ask your questions in the Q&A box, and then Joe can answer them for you. So for the first question we have, how do you balance the trade-off between security measures and system performance in critical systems like ECUs and ADAS?
Yeah, security and system performance is a key thing. And I believe there's a lot of security systems out there that may actually slow down the system overhead. And it's always difficult to measure, but you can find where a process starts and a process stops, or a series of processes that start and stop in your system. And so what we've done is we've worked with people to say, yeah, find that common component, that end-to-end process to measure system overhead response time. Does it take 5 milliseconds or 12 milliseconds on average? And then use that to test your security measures in that exact same way. And what we found is there are some systems that might slow down that system, including autonomous systems, which is a non-starter from a security and a safety perspective. If systems are slower, it's also a non-starter from a cost perspective, because someone may have to buy more hardware. And so if you can provide security protections that don't require additional overhead at runtime, say on an ECU or on an autonomous system software platform, then you have the chance then to really innovate and not slow things down. And so with runtime protections that don't have agents on the software, that don't add new lines of code to the system itself, those are the kinds of techniques that are needed, and the kind of innovation that at RunSafe we've always looked for. How can we add in security without slowing down systems? So it's obviously right up the alley for RunSafe to talk about that. And we joke we want to run safe fast and run safe securely and run safe, certainly, without slowing down systems or adding friction to developers.
Great, thank you. Our next question is, what strategies exist for securing vehicles with outdated ECUs that lack update capabilities?
That's obviously a tricky thing. Today, if you have a 20-year-old car that might have, some form of software on it, you're probably not going to have any updates or any means to do, that kind of, capability. That's part of the reason why I think automotive manufacturers are interested in over-the-air updates, more software, and looking at business models that allow them to provide ongoing service as part of their service repairs, or just as a subscription to consumers at some point. And we can manage, software updates that are in fact things that can be done. But today, it's very hard for those older ECUs to even be updated. And so that's a challenge. It's also a challenge, though, even going forward. So if you can build in the security mechanisms in the software development lifecycle, instead of trying to bolt it on later, then you do have a chance, even if it's an outdated ECU, to protect that ECU from cyber attacks. And so that's one of the key aspects then, is to look at your software development lifecycle, look at the things that can be built in, not bolted on, and use that as a means to extend the life of, from a security perspective anyway, those ECUs.
Thank you, Joe. The third question is, what safeguards are recommended for managing third-party software and software supply chain risk?
Yeah, I think for example, in the autonomous driving systems, what forces everyone to get in line ultimately are the safety standards that are out there. And with safety comes, an expectation that ultimately the OEM has to produce all the artifacts that are consistent. And so those flow down to the suppliers to ensure they're providing things that meet those standards as well. But with that said, there are ways to assess security requirements and security vulnerabilities of third parties that might put those safety items at risk. And so one of the things we're starting to do with our business partners and our customers in the automotive space is to help them analyze their supply chain and get ahead of these issues, and then use that as a transparent way to communicate with suppliers on areas of vulnerability. The other way is to also require these suppliers then to ship with the software or with the component a software bill of materials that could potentially then include the vulnerabilities associated with that component. And that transparency, that visibility allows for communication and allows for coordinating security best practices to address that third-party software risk. And so even if it's not a tier one provider, maybe it's a smaller company, companies who provide a software bill of materials to the OEM, to the suppliers, what that means is everyone has a better chance then to catch up and ensure and anticipate certain safeguards that have to be put in place. But ultimately, it's the safety standards. But I think that becomes a costly process that can slow down the manufacturing process. And so I joked about making it go too fast, but we don't want a lot of delays in the manufacturing process because that becomes economically not attractive for the car manufacturers. And so there are things that can allow OEMs to reach into the supply chain and get ahead of these issues by virtue of leveraging SBOMs and some of the other standards.
And how can teams foster collaboration between safety, ISO 26262, and then the cybersecurity, ISO 21434?
Yeah, and good news is they're complementary in the fact that security vulnerabilities are in fact safety issues. But one of the best things that can be done, and we pursue at RunSafe, is to certify our software tools, for ASIL certifications and the like. And if you certify the tool, then that tool can be given to software development teams to ensure that by integrating that tool, they can meet those compliance requirements. And what that means is mapping security controls to those things that affect the safety controls, but also it's really focused in on the software tools that can help enable that in a programmatic way and not in a manual review way.
Great, thank you. And this is our final question. Just a reminder to ask any questions. So that is, what automated vulnerability detection tools are most effective for identifying memory corruption risks in embedded systems?
Yeah, certainly there are great providers of static and dynamic analysis. You can also look at pen testing, red teams. All these are ways to look for memory vulnerabilities. There have been studies that show that memory vulnerabilities are in fact difficult to uncover. And so that's one of the great challenges from a safety and security perspective is if we don't do a good job of detecting these memory vulnerabilities, and they're the highest class severity memory vulnerabilities, and they are the types of ones that could put safety programs at risk, then we need to do something over and beyond testing for vulnerabilities. And that would be to look at eliminating the entire class of vulnerabilities. And there's a couple ways to do that. One would be to rewrite all your systems in memory safe languages like Rust, which of course takes a lot of time and would slow things down. And I know the problem is that software development teams don't necessarily have Rust developers. They also have interdependencies with other systems. Some of the operating systems are only now catching up to support Rust applications, if you will. And so there's a lot of challenges to doing that. But probably the most important one is the time and money it would cost to rewrite systems. And so The other method is to apply software memory protection at the point in the build systems that don't require a single line of rewriting code, much like what RunSafe provides. But over and above that, I think, so addressing the class of vulnerabilities is a key step, along with, even automated fuzzing, red teaming, different forms of security testing, static and dynamic analysis, and the like. But you also can look at, then a final point is, by leveraging software bill of materials and really getting strong, complete visibility into the software components in your supply chain is also a great tool. And so what I mean by that is, if there are some open source software components being shipped, there are times when the OEM may have in the past never even known about those open source components on the vehicle, in these software systems. And so by having a software bill of materials and linking to all of those individual open source components that are packaged into a product that gets shipped to the OEM and ultimately assembled into the car, it's a great opportunity to identify components and their associated vulnerabilities, whereas scanning tools and these other testing tools may not know to test for those components, may not know those components are there. The software bill of materials may provide a layer of visibility in the open source software that's being shipped. And that is a very mature process. Open source software, when people find vulnerabilities, they disclose those to the open source community. And there's matching a CPE with a CVE. So the common platform enumeration, which is the component, to the common vulnerability enumeration system, the CVE, that's the vulnerability. Matching the component and its vulnerabilities, and inheriting all that data knowledge, that threat information, that vulnerability information, by virtue of having a robust, secure software supply chain system for software development. What that means is you have more visibility in your underlying vulnerabilities. And that alone gives the industry a chance to communicate about how best to fix vulnerabilities and which vulnerabilities they need to address before they ship the cars.
Great. Well, they were all our questions. So thank you so much, Joe, for answering those. We still have some time if there's anything else that you want to uncover.
I would just close on, really enjoyed being able to walk through these points, and certainly thank you, Bethan, for arranging this discussion. And I'm grateful for the response and the interest in this topic. What I would say is, a key thing that every organization could do to help understand the complexity of security issues or risks in their software supply chain, in their supply chain in general, is to develop this robust way to look at risk reduction across your supply chain. And so I'll just draw attention again to the slide and the QR code, and we would love to talk through risk reduction strategies for your software systems, and given your software development lifecycle and the practices that you have in place. But I think there's lots of innovation in the security side to enable a very safe driving machine going forward. And certainly RunSafe is happy to participate in the ecosystem. So that's my closing remark, Bethan.
Great. Well, thank you so much for joining us and for sharing your insights.